Hello, good morning, happy Wednesday. I successfully did my morning routine without dropping tea all over the desk. So that's a win for today. We're also halfway through the week, which is another win. So let's take a look at what we're doing today. So we have, actually bring that up here. Go up, nope, there, nope, there. Okay. Yeah, so we're gonna, oh right, create the game state to hold the games in. So right now, let's go ahead and set up the entire system because this is a two-parter. We have our back end, and for this back end, it's running a WebSocket. We're using Tungsten Async for this, and we're sort of going off of a async sort of like Echo server that they had showed up. I guess like maybe not Echo, but like a broadcast server. And this runs in the Windows PowerShell. So we have the socket server listening, and then come back to here and we're going to go to the front end where we have a view application. And let's see, wanted to test. Can I open up? I can do new integrated terminal. But that doesn't like. Yeah, I can't like type in Ubuntu. I bet there's a way for me to tell it like what kind of terminal I want. But that may be. I'll probably have to look into that like off stream or something. I don't think I could probably do the terminal settings, but like usually I want the Windows mode, but like when I'm doing web stuff, I want the WSL. So, oh well, let's oh, there we go. Okay, create the new terminal with profile, and that lets me open up straight into WSL. Don't have a PowerShell one open at all in this project. We are using Node 14 for the LTS version. So let's see. It usually doesn't take too long to like restart all this. Okay, there we go. The front end set up, and here we go with our lovely app so far. We have this create game. Now, this button, I mean, it looks like it tells us that it's creating the game, but we're not really getting any messages back. And if we look at this, we do have an incoming message with a command that's creating the game. So that's the last thing that we did. So let's head over to the library. Here's where we're basically creating that using JSON, and then we're just debugging this message. So I think our next step is to have some kind of main state. Whatever our main state has to be in is going to have to be arced and mutex, so we can actually get access to it, because each of these are going to be inside of a where is it? it's an async function. So basically it's going to be its own thread. So where do I want to put that? I might want to put that in its own thing. So let's get like main state. And we know that we're going to want to track the games, right? So this is going to be the specific games that we're going to be creating. And I think those are going to be stored in, because we're going to have like a key. We're gonna have a key and we're gonna have to put in like who's in the room. So I might need a room state too. If I'm just creating the key for right now, what if I don't even store this? What if we just impl this to do that? State. I'll probably, let's see how long you can get with a default here. So just a drive. Sure, debug. Yeah, default. Okay, so for main state, I want to have a pub function create like a create room. And we're gonna want to return a room code, which we're just gonna have be a string for right now, or should this be a number? I'm kind of thinking of having this be a string, even though right now I'm probably gonna just make that as like a random number between 0 and like, or probably between like 1,000 and 10,000. Which does mean we need rand. What button did I click to do that? I think I clicked Control Windows at the same time. Okay, so when we create the room, we're gonna want to, well, we're probably gonna want to store the RNG for later use. Although like recreating this again over and over again, probably not that big of a deal, but we're gonna want RNG. There's a lot of RNG in this game, so let's go ahead and store that. So we're gonna have RNG, and you're gonna be a thread RNG. I think then in this case, okay, so it can handle default. So this works with default. That's awesome. Okay, so we create room. What I want to do is create a number, and we can have this be 4 digits or 5 digits. I'm thinking 4 digits for right now. And then if we run into like collisions, we could then swap up to 5. We can add letters in, all sorts of fun little stuff like that. So if we have RNG, I want to gen range. So let code equals G gen range. Okay, and then the range I want. So it's 1,000 to, and then this is exclusive 10,000. And the idea around this is it's not exclusive. It's exclusive of this right-hand number. So that'll be essentially just 9999. So that should guarantee to be a 4-digit number. Then I want to essentially turn this into a string, code.into. Can you not turn into a string? No. Okay, fine. How about code.toString? Yeah, that works. Okay, back to here. We, in run, this is where we're, so like previously our state is like this peer map. We're almost completely gonna be replacing this peer map, but I'm gonna worry about that later. So we're gonna have main state. Now we do need to arc and mutex that. And I do kind of like this type here. So they have this type peer map. I'm gonna do a type wrapped main state. And then this is gonna be main state inside. So we create main state and let wrapped state is equal to. Well, first ad, you made your first game. Awesome, that's great. How did it go? And what exactly was it? Snake and N curses. Oh, fun. And N curses. Is that a Python library that lets you control the terminal? Or am I thinking of something else? Oh, it's a C library. Okay. Yeah, I'm not super familiar with those libraries. Okay, so we do that, and then we'll throw in main state, give you ownership here. Now, this being said, I wonder if it would make sense for our main state just to return this. It's like this works, but perhaps what I should do is we don't need to do a default here. It's like if I create new wrap, and I don't need to take anything in, and we're gonna return. Okay, so this is where I'm gonna take this type, cut you out, put you in here. So, okay, typed wrapped main state is this. And so we're gonna return a wrapped main state here, which I guess should be simple. So we can just do let state equals. Actually, here's where we can do default. Default with that. And then we're going to return. So this can be a arc new mutex new, and then main state. So this way I can just call new wrap, and we get this out. So I don't need to do you at all. So we can actually just call this main state is equal to main state new wrapped. Okay, perfect. It stands for new curses. In the old days of BSD, there was another C library just called curses that enabled Unix-like systems constructions of TUI applications. It was replaced in 4.4 BSD by the GNU project with ncurses. Oh, nice. So it is a terminal UI application. Oh, nice. I haven't looked too much into what options for terminal UIs are in Rust. I've seen some people share some share some crates here and there, but I've never really like paid that much attention. Okay, so then what I want to do is like for this handle connection, we have this state, and oh, notice that this is cloned. So this needs to be clonable, but that's fine because it's an arc. So definitely we can do that. So let's add in, we're gonna be replacing state. So we're gonna just put in main state here. We're gonna also clone it, which means in here for we have the peer map and main state comes in, which is gonna be a type. What do we call it? Wrapped main state. Your type needs to be public. So that way we can find it. Okay, so we now have that main state in here. So we have our incoming message, which means we can also check what the command is. So I wonder how I want to do this. Probably like maybe a match on the command, or maybe like a handle command function. Oscarellen, hello, good morning. Let me try just doing it right here to begin with. So we're gonna match message dot is message. Do we have a public? We need to have a public command. Okay, so then we're gonna use create game out of this. Okay, so if our message is create game, or if the command coming in is create game, then we want to tell the main state to create the game. So the way that works, we have to lock. So we're going to take main state, we have to lock it to get into the arc, and then we have our mutex, but we should be able to automatically go into there. We want we have to unwrap after the lock, and then I believe we can do the thing, because you're this arc mutex main state, and main state we have this create room. Okay, so lock just returns a mutex guard, so we don't need to do this. Although all of these other ones, like peer map, lock, then unwrap, and then insert. So it kind of feels like we have to. Oh, do we have to lock mute? No? Okay. So that locked main state equals that. Okay, so we have now you lock this. Oh, just to insert off of there, and then you're done with that. And then here's the same thing. We get the peer. Okay, so we get the peers out of this. So really, it's just like, is Topio mutex, then lock that await, is that needed? No, this is a this is an arc mutex, not a Tokyo mutex. At least I don't think so. Let me take a look at what mutex. Yeah, this is standard sync mutex. I don't know what the difference is. Maybe Oscar Ellen, if you know, you can maybe describe it. Okay, so now if I unwrap you, like suddenly you have no idea what's going on. Air map. So here's this wrap main state. So like we have these coming in. So they should be fine. The Tokyo mutex integrates with the event loop. So the thread will yield control to other tasks if the mutex is already locked. Oh, nice. Okay, so it doesn't wait. Oh, okay. So it doesn't block while waiting. Oh, that's good to know. So I guess like, why can I do that here, but not here? Like, why can I also do that here? Because here, this just works just fine. So our main difference here, main state is a wrapped main state, in which if we look at it, that's an arc mutex main state. And here, pure map is a arc mutex hash map. So really the big difference is instead of a hash map, I have like a main state struct. And also like the next question is this really a problem, or is this Rust analyzer telling me that it's a problem? Okay, let's say I just do this. I just run that command. Let's do let game code equals this dot create game. And let's try running this. Oh, method not found in impl features future. Did I somehow like pull in unwrap from somewhere? You could be right. Let's double check. Oh, it's an that's the wrong type of mutex. Import mutex from standard sync. There we go. Thank you, Oscar Ellen. Okay, that's fun. Okay, so then we have dot create room, and this gives us a game code there. So then we're gonna want to send this game code back. So let's say I just debug what the game code is. Oh, wait a second. Await occurs here with main state may be used later. Wait, where is that? Future return by handle connection is not send. I don't need to do you anymore. So task spawn 77. Okay, so we need to do this task spawn. Now the big thing that I changed in here was adding the main state. So await occurs here with main state, may be used later. The main state is dropped. Okay, so I'm trying to create this. I'm trying to follow this pattern with state here. So we create this. Now this is an arc mutex. We should double check the type of arc too. Standard sync. Main state. Okay, standard sync, arc and mutex. So that's good. Yeah, I think that will also be once I learn a lot more about async stuff. I think that I want to, well, the other thing is like async still seems to be going through a little bit of fluidity when it comes to designing. Is the called function and async func. So, let's see, we're talking about line 7. Okay, so here's our problem. Future cannot be sent between threads safely. Within main state, the trait marker send is not implemented for. Oh. I was trying to store rand. I don't think I can do this unless there's like a rand async. So RNG is not thread safe. Therefore, I shouldn't even try to store this. So when I create this, I'm going to have to create this first each time, at least until I figure out something better. Then you don't become self anymore. And now you're working. So then come back to here. We establish a connection. We create game, and here's our random game code, and that's going to come back. Okay, so that's what the problem was. Like, RNG from like rand doesn't implement send because it's not thread safe. I think this is like the first app where everything that I've done is essentially now going to be in threads. That's going to be fun. Okay, so now we have our game code. What we need to do is send it back to our sender, like back to whoever sent this to us. Now we have our address, and we can take a look. What they were previously doing here was broadcast to everyone other than this address. But what we want to do is store the address. I don't think we can. Let's see. This is WebSocket out. So we can do sender. Okay. So we're going to want to store the addresses of all the connections in our main state. Like very similar to what we're doing here. So like a hash map of socket address and then the sender, which is, okay, our sender. These are peers. So we peers, we iterate through it, we filter. So I want to do the opposite. Find the filter, which should be a simple get for a hash map. That gives us the sender, and then we can use that sender to send out a message. Which means in here, we want I believe a hash map. I know. Don't think about it too hard. We're gonna try to make it a little bit better as I'm sort of like refactoring here. So maybe we can have like clients. And clients can be this hash map. And we're gonna have now you are this socket address. I guess I'm okay with like using this for right now until we figure out a little bit better. So socket address, which is that a standard net? Yes, it is. And then we're gonna have a sender, which you are an unbounded sender. Oh, right, because we have this type here for this sender. But I can just call you. So you're an unbounded sender, which is from the futures channel. Yeah, futures channel MPSC unbounded sender. So futures channel MPSC unbounded sender, and then what are we sending? I think it's just a string. Oh, it's a message. Oh, it's a tungstenite message. So this is what we're storing in here. Now, does default still work? It does, okay. Okay, then we need to store this client in here also. Where are we storing that in? Like here's that state, which is the peer map. That's being passed in here to handle connection. Right here, look at that. So peer map, lock, wrap, insert, the address, and the sender. So I want to move this over from using the peer map to ours. So we're gonna have a method on here. Add client. And then we're gonna take in an address, which is this socket address, and the sender, which is a unbounded sender, the message inside. I don't think we need to return anything. What we're gonna do is just say self dot clients dot insert address sender. and replace whatever previous one was in there. So back to here. So where we're doing this, we're gonna do is main state. I'm gonna lock you, unwrap you, and then we're gonna do a add client, pass in the address and the sender, and we're good to go. And you've been owned, so we can now remove you. So at this point in time, the peer map is completely unnecessary. So I can remove that from this list, and you don't go in here, and we don't even need you here. Which also means you two aren't needed. So overall, we're removing more code than we're adding, which is good. Best feeling in the world, at least when it works. Okay, so we've now added this in, which means we want to send to sender. We want to send a message to a specific address, which is going to be this code, right? Now we already have this create room here. You know what I'm thinking? We grab this out and this becomes like game state. Maybe the main they just state for that. Then from state from that, we should be able to then run the things. So like let code equals state dot create room. Then I should now be able to run another function in here. So in our main state, what are you upset about? Yeah, okay, we're not doing anything with you yet. Okay, so the next thing is gonna be send hub function send message to address. So like this is send one. I think we have to have mutable self because I think the sender needs mutable self. Then we're gonna take this address. And then we're going to take the message, which is, okay, so before we do that, we have to come back to message here. We have these incoming message. Let's go in and outgoing message. So this is going to be, we're going to derive the same things essentially. And so here is game code. Maybe we should call this like a room code. Room code, and you're an option with a string. Because you could be none or null in this case. Okay, so then message is going to be an outgoing message. And I think we can return an error result. but we don't care about what's in here. So we're going to do that. Okay. So then our idea here is we're going to take this out. Okay, so we need to get the sender for this. So that's the first thing. So that our sender is going to be equal to self.clients.getMute and pass in. Okay, so you don't need, you can just be a reference to the socket address. So address. If it doesn't exist because like the client dropped off or somehow like, you know, left the game, we should handle that. So this should be an iflet. Sum equals you. Okay. So now we have our sender in here. We have our message. So time to just send it, right? So we're just gonna say, oh, but you need to send like this specific type of message. What is that? Is that like a string? Oh, it's gonna be a string, I think. Because if we take a look at what this was, send message. Oh, that was this message out here. It was like sending this message straight back. Oh, but I've lost it. I've shadowed it and lost it by accident. I don't want to do that. So this should be incoming message. Oh, and so this is incoming message. You're the original message. So I can do a toText to get that out. But now we have this incoming message that's been converted. Then, okay, so we create the game. We have our code, so state create room. Okay, so do I create a so this was just like sending this out. I wonder if I can create a new message. This is the message type is the tungstenite message. Okay, so it's an enum. Okay, this is easy enough. We're just gonna send this. Message, text, then a string. Okay, super, super, super easy. So our outgoing message we're going to wrap that in a tungstenite message. So what is that gonna be? That's gonna be, take the sender, we send, is it unbounded send? It's unbounded send. Okay, and then this message, so that's gonna be a message, text, and then can I just do it like a toString, or do I have to do like a JSON? I think I can just do a toString, right? So that's going to be message dot toString. Okay, so it can't do that. I guess there's a Serde JSON. Oh, I think it's sort of JSON toString. And then that's the message. No? Expected struct string found. Oh, result. Okay, so then you need to be a reference here. Okay. Okay, so that's gonna send out. So then back to here. Okay, we need to create the message we're gonna send. This is gonna be an outgoing message. If we take a look at outgoing message, we just have this room code. Do I want to create? I'm thinking we probably want to create some kind of like either builder for it, or let's just do like a new function to begin with. So this is going to give us a room code, which is going to be an option with a string inside. And we're going to return a self. Okay, nice and simple. So new, and then the code. Oh, it has to be a sum code. That gives us this outgoing message. And now we can say state.send message to address, a reference to the address, and a reference to this message. And we'll unwrap you. Okay, there's no error showing. Now with you, I don't think I'm handling any messages coming back in, so we're gonna have to get that working. So right now we have this like connect to server. I'm thinking about like throwing some of these functions into like an API file, because like, let's see, connect to server. Yeah, we're adding these event listeners. Also, this try catch didn't do anything for us. So like this is completely unnecessary. So then we have our removing the try catch because it didn't do anything. I tried to add it in like to catch an error that I got, didn't catch the error. I have to instead catch the errors using these add event listeners like that. But I guess like the problem is, oh, like I can pass in commit, but that seems like I don't know how useful that is for here. I'll have to think about how to refactor this a little bit later. So right now we have this like add event listener. Oh, you know what we can do? We can throw these we can throw these into like different dispatches. So we could have another action to like listen for errors. And then you go down here. So we're going to take in state. So So we can do a state.websocket for that. Okay, so we're gonna commit, and then after we commit, we want to do a dispatch. And we're gonna do a listen for errors. So that like cleans it up just a little bit. We could potentially throw some dispatchers into another file if this gets too nasty. Which is where like that module section at the bottom comes in. Okay, and you need a commit here. Okay, to make you happy. So then the other thing is we're gonna listen for incoming messages. And I wonder, this should probably be, okay, I'm gonna change this. Instead of listen for errors, we're gonna make this handle web socket errors. Handle socket messages. And we're gonna, okay, so state, WebSocket, add event listener. And I think it's just message. And we're gonna get the event. I just want to console.log that event out to begin with. And that's all. And so then you connect to server. Now we're going to dispatch handle WebSocket messages. It's not that it's asynchronous. It's more of like errors don't get thrown, they get passed as a message. I think that's what the problem is, or that's why like the try catch doesn't work. Okay, so if we have that, now I want to reestablish a connection. I create the game and we get this message back, which includes data, which is here, this room code, and we get the room code. Okay, awesome. So if we create a game, I want to now move us to that like game, or at least like to throw in like, to put like what game that we're in. Which is going to be interesting because like, how do I know that we're now in a game? I mean, we can watch to see if like the room code gets updated. Or am I gonna have to create the game some other way and not do that to the store? Or is it not a room? And like we just load up all the stuff here. That might work too. I kind of feel that I want to load up into a different room though. So after we click create game, I want to navigate to another room. Also, this data, we need to like store that away. So let's do that too. Here we have their message. Let's do room code. We're gonna start that with null. So it's falsy. And then we can get, so it's message equals JSON.parse. Now we can try this. Let's see if we run into any troubles with it. Event.data. That gives us this message, and we saw that inside the message we're just going to have this room code, which we'll throw in here. So that'll be a commit. And that's a set room code. So if I run this now, we should be able to, in Vuex, we can see room code is null. I hit this and load the state, and room code is now 5298. I also want to move us into a game. So that's going to be indexed in a router. So we're going to want a new route in here. So probably a path. Maybe like games. Oh, I think we want like games and then the room code in here. Is it like this? Room code? We'll find out. To do the component, okay, so I need the component first. So we're gonna have in the views here, I guess like the room. All right, cool. Nice for you to not help me out here. Let's see. Then we could just probably for right now just have an H1 with a hello in it. Or maybe this is just like a room. So in here, games / room code. Name is going to be game, and component I called it room. Okay. Then in our main app, actually no, it's in home. So after we click on this button for create game, we emit create the game, and then I also want to head over to that room. But we can't really do that yet, can we? Because we need the room code to do that. So a little bit of a chicken and egg problem. How do I know where to go? Maybe I shouldn't store that. Maybe I can't store that in the URL. Maybe it should just store in the. Okay, so yeah, I don't think we can go into the path. Otherwise, I have to wait for this to happen, and that's not gonna happen. Here, because if I console log, like the entire point about this is it's all asynchronous. So if I console log like this dot store dot state dot room code, I'm guessing that this is going to be undefined or null by the time this runs. Yeah, it's null, but if we take a look in here, it's not null anymore. So we can send us over there, but we can't do this thing because we don't know what that is. So we're going into a rooms. And I don't think I have access to the router in the store. Like, I don't think I can do anything here. So let's... if I do a log this... I have access to this. Do I have access to... Is it like route that push? Okay, so it'd be normally this dot dollar router dot push. So can I do this dot dollar router dot push slash rooms? Yeah, okay, this dot dollar router is undefined, so I don't have access to it at this point in time. So like, I don't have access to you. I mean, I could pass that through here, but that seems to, I don't think that, I think that's an anti-pattern. So I don't want to do that. Instead, we're gonna head over to the rooms without knowing what it is, knowing that we just requested it. So we're gonna do a this dot emit not emit, this dot router push slash rooms. And that takes us to room here. Okay, so that's fine. Now we're gonna want a game code to be displayed here. Which I guess like I've changed it now. It's like a room code, not a game code. So in room, you are in room. It's like room code. So we're gonna want a computed property. Room code in it. And all room code is going to do is like just grab this out. So we're going to say turn this dot store state dot room code. There it is. You are in room 5522. So if we hit this now here, if it never shows up, we obviously have a problem, right? Maybe I should do something like after a little while, it like kicks us back or like sends an error message. Maybe I shouldn't worry about it too much right now. So if we head back to just here, create the game, we're in room 3857. Obviously this should probably be a link to head back. Probably nice. But okay, so you are in room this. That's great to start with. Okay, so that's creating the game state to hold the rooms in. That's a good sign. There is that. Now what's next? I think we want to be able to join the game. So join a room. Let's see, join a room, and then we also notice that we want to like handle joining like a room that doesn't exist. That'll be later. Okay, so let me go ahead and commit all these things. So we can create a room. All right. So joining a room. Let's actually make it so we can go back, because that might be helpful. Front end. So in our main app here, I want this H1 to be a router link actually. So I think I can do this around here. I can do a router link to slash and that just gives us this right away. So even if I hit refresh and we're here, I can now come back to here and create a new game. As many games as I want.
Hello.
Zilby says hi. Okay, yeah. So if we do that, then the next thing is joining the game, which is gonna be some kind of like input. Oh, okay. You're done. Oh, you want to go over there? Hold on. We can get a camera. I need like one camera for each like direction that Zilby can be in. Right now I have to move it constantly. It's on all the different places he likes to hang out at. I think that might be too far to the left. Let's try that. There we go. Okay, so we want probably like an input. So we have create game, and then like a join game shows up. To do that, we're gonna need a text input. So we've been using these MWC, which I should just put a link to down here. So what was it? It was like oh, done already? Oh, okay. Yeah, material components, web components. And I want a text. So not a text field. And that's pretty simple to sort of like set up here. So we're gonna go ahead and install you. I should set up a .env file for this so I can just use mvm_use or have it automatically determine what to do. Okay, so then in you, paste you in and start installing that. Okay. And we're gonna, in our components, let's create a text field. Probably just call this like a custom. Okay, we're going to import this custom text field. Then inside of here, it's just going to be simple that. Now for label, my text field, well, we can start this. Then we'll pull that out. So we're going to go into room. No, wait, this is actually home. Let's just put this right down next to it. There's our custom text field. That is huge, but okay. This button is like half the size. I wonder. Yeah, no, even I'm zoomed in, it's pretty big. But okay, so we have it set up like that, which means we can now maybe set up with like a label. Like join room or join with room code. So then, oh, well, okay. We'll put room code here and probably another button. So I think we're gonna want a div. And then another one of these custom buttons here. So we're gonna have room code, and this is gonna be join with room code. Okay. I mean, not the best looking. We could probably do a lot more to like make this look better. I mean, I don't, not probably. We definitely could make this look a lot better. So we want you room code. So as I enter this, I want it to probably come into data. I could look at Jackbox as a reference. Yeah. That's probably a good idea. It's been too long since I like played any of those games. I forgot completely what the interface looks like. Maybe I'll do that like off stream. Now the fact that I'm making all these as components, we can refactor this and make it look however we want a little bit later pretty easily. So I'm not too worried about that. Okay, so room code, we're gonna enter in something like, you know, like that. So I want this, when we hit join with room code, we're going to emit up. So to dispatch, so we need the room code in here. So we have methods. This is going to be our training room code. We're going to set you as just an empty string. So that means we need something like an on input. So like at input. We're going to have a method. I guess like just handle join room text field. And so this, we want to take in like this actual text, or I guess this is going to be the code. And this dot code equals code. Okay. So then that's input. So we want to come back to custom text field and at input here, handle input. Okay, so we're gonna take in like the raw input, I guess. Let's console log that out. And then we want to, I guess like I don't need to do anything right now. We'll just console this out, sort of see what happens. So in here, as I start writing, we can see that we're getting this input. And now I know how to get in here. I've used this component before in previous like actual work projects. So the way to get it, because like this is, it's not a view component, this is a web component, and it doesn't know what we're using to get out of there. But what I can do is raw input dot target dot value. and that gives me exactly what I want to get. So I actually want to do a this dot emit input and raw input dot target dot value. So then by doing that, we can take a look at our home component here. So joining room code is empty. I then type in there, hit refresh, and that's what we've got. So that's being updated for us. So then as soon as we hit join with room code, we can take that and emit that up to then do our join. Okay, so that will send up our joining room code out. We can actually see that without handling this in events here. So as soon as I type you in and I hit join with room code, here's this create game, and we can see the payload. Oh, it's empty. Well, that's. Oh wait, did I hit the wrong thing? Oh, I didn't. You know what? Because you are create game here. So I need you to be handle join room quick. That's what it is. There it is, join room, and we passed in the room code that we want. Now this goes up to app. So with this event, we're actually taking something in, which is going to be the room code. Now I can like console log that out, but we want to dispatch to then join a room, which is going to send a message saying to join a room. So let's just do join room. This dot store dispatch join room, and pass in that room code. And then as soon as we join the room and pass the room code, we probably want to. This is when we want to like now change. I do wonder if we should like, if we watch, so we have this like message here. If we like watch that room code in state, we could watch the storeroom code. And as soon as that gets set, we could then switch over to it. That might be a good idea. I kind of like that. But okay, we're gonna just do this for right now. So dispatch to join room. Then in the store. Then we're gonna have the room code here. So for right now, we can then do a creator message. So command is going to be join room, and then the room room code is going to be the room code. Okay, so that gets sent down to our server then. Now this handle the WebSocket messages coming in. This is where it's going to be interesting. So like right now, I think this is going to be fine because we're going to have like a room code set up here for that. But we're probably going to want to have like if statements in here, or maybe like other dispatches, or yeah, probably like to handle like what is in this message. Because like this is going to be like the entire game, like all the game stuff is going to be in here. So we're probably going to like figure out what's in a message and then dispatch to those. To try to keep these really small. But right now, this is what we're doing. So if I do this, I'm assuming this is going to crash. If I try to, let's create the game. So now we're in 5977. And now I put in 5977 and I join with room code. Yeah, we unknown variant join room expected create game. So this is in message. No. Yes. Maybe incoming. Okay. So it is command. But we have create game. We also have join room. I think that's what it was. Join room, yes. And then room code. So hub room code is going to be an option with a string inside. I would have been helpful if I saved that, wouldn't it? Okay, now we have our non-exhaustive patterns because now we have to handle this. So fill the match arms. Okay, so now if it's join room join room, we're just gonna leave this to do in here. Maybe what we'll do is debug out this incoming message. Oh, sorry, accidentally hit the microphone. Okay, so game. Yeah, kind of need to refresh. So yeah, this is something else. We're not handling handle web socket dropped, or yeah, like let's handle WebSocket drop. So that'll be another thing to handle. Okay, so I'm gonna come back to here, hit create game over here. Join with this room code. Here we go. Okay, so command is join room, and room code is this. Which means the other one should be a none in there, which is fine because when we're creating the room code, we don't have a room yet. Okay, so we now have a room code in here. So if we want to join a room, how is that going to work here? We need to associate clients with rooms. Now we have right now the addresses. It's like just the clients here. With the socket address, we could, that socket address seems to be clonable, or at least it seems to implement copy. Right now, can I? Yeah, okay. So it is, this address is fully clonable, which means that we can now in our main state hold all of the rooms separately. So all the clients are here and they're just stored in here. But now I can have the clients which are like they're essentially client ID as a socket address. I then want to store that by what room they're in. So we can have rooms, which is also going to be a hash map. And then here we're going to have a room ID. That's going to be a string. And then the socket address. So when we create the room, we're going to drop the player into it right away. This is nice that we've created the room. Oh, and it's not going to be socket address. It's probably going to be a vec of socket address. So like there's a bunch of them. So then we're going to take this code. Before we return what that code is, we also want to add that into the room. So self.rooms insert Well, this is going to be interesting is if the room already exists, I kind of want it to return an error, don't I? So let's actually have this return a result with a string for the room code inside. So what is our options? Contains key. Probably retains key. Oh, there's a try insert. Tries to insert a key value pair into the map and returns a mutable reference to the value and entry. If the map already had this key present, nothing is updated. An error containing the occupied entry and the value is returned. Okay, so that's kind of what we want to do. So key is going to be this code dot clone. and the value is just going to be an empty vector. We should probably take in the address. And we'll throw that in there. Okay, so this returns a result. So we can just do this then. Self.rooms hash map. No field rooms on type main state. Well, oh, what's going on here? That's what's going on. Okay, now you're happy. And wait a second, you're not happy. Try insert. Oh, use of unstable library feature. Oh, that would have been so nice. That would have been nice. Okay, never mind. We have to do this manually first. So if actually I think we can do if self dot rooms dot contains key unstable too strong. I know. Okay, so this is gonna be code. Okay, we could just do a reference to the code to begin with. Okay, so if you return a key, we're going to bail and we're gonna say room already exists. But if we get past this, then we can a self dot rooms insert key is gonna be the code dot clone, and the value is gonna be the address. And then we return this code. Oh, a vec with the address. And then you're going to be an OK code. Okay, so we're just going to go ahead and unwrap here. We should have some kind of error in the future for like, oh, like pass that up. So we need to turn errors when they happen. Okay, so we have to pass in the address. Now, can I just do this or do I have to clone it? I think address implements copy. Nice. You know what would be really nice is if I can highlight this address and I can see, okay, what is its derives? Like if there's any direct derives, like copy, clone, that would be pretty cool. Otherwise I have to like come here, go to socket address, and then I can see, okay, it implements copy and clone. Okay, so then in join room, so that's create game. In join room, oh, how nice of my my watch to tell me that it's 8:15 now, when it's clearly 8:31. Oh, that's lovely. Okay, so in that case, I do have to get ready for work. Let's see. So we do have this incoming message here. This is gonna be the very next thing. So basically it's part of this joining room. I guess you can't see it when I like highlight my like text of what we're doing, but that's all stuff above me. So joining a room is gonna be the next thing we're doing. And yeah, I think that's gonna be it. So let's go ahead and commit and send these on all up. Close all these down. I know there's like a bunch of stuff that's sort of like left undone, but that'll be fine. That'll help us remember what we're doing next time. So this is, we are joining a room. I'll push you up. For you, we are allowing a client to join a room. And push that up. Okay, excellent. So